Okay, up here, guys, this is it. Last unit we have. This is a very short unit. It builds on trig graphs, the quiz you just had. Okay, so each of these they're going to have a word problem, and the word problem embedded in it is a trig graph. Okay, that models that particular problem. So that's what we'll be doing for this week. So the lessons this week. Let's see what we're going to cover this today and tomorrow, and then we review on Thursday. So I see you Tuesday, Wednesday, Thursday. Lesson, review. Don't see you Friday. Quizzes on Monday. Okay. So being here, I think, is important for this. Okay. So let's see if this is. So guys, what we're going to do here in modeling things with trig graphs. So there are things that happen cyclically. You know that this trig graph, we've been drawing these things over and over. They just repeat. So it's a model of waves, of peaks and valleys. It keeps on going. So what are things that happen repetitively? Think about temperature. You wake up in the morning, the temperature's what? Cooler. During the course of the day, it gets warmer. In the evening, it gets, and then that repeats. Okay, so it changes a little bit. So like in the summer, those temperatures are all higher. In the winter, those temperatures are all lower. But you can see, based on sunrise, you can see a cyclic nature of that. Other things that are cyclical, the tide. When you think about the tide coming in and going out, those are things that run in cycles. So a lot of things can be modeled with trig graphs. So here's just an example of daily high, daily low. You see, like if you look at this, if you take the data, you see you could model it. You really can't model it with a straight line, but you could model it with something that has a curve or a cyclical nature to it. So we're going to do a few examples of word problems, applications that do that. Let's just consider another example, and we'll work this a little bit later. You got a bicycle, okay? The bicycle, what does it do? I mean, what does it do when you pedal it? What does it do? It goes forward, but what does the pedal do? It moves, more specifically? Yeah, so it goes around and around, but like if you were to look at it on a graph, I could model the height of this pedal. This pedal right now is at the top. As I pedal, where's it going to go? Down, but then it's going to go where again? And it's just going to keep on doing that forever. That's all that the height of the pedal, that's all it's going to do is just go up and down, just like this, okay? What would the period tell me about that? What is the period of a graph? Right, but in context here, the period tells me how long until the graph does what? Repeats, okay? So what if my bicycle pedal was repeating faster than your bicycle was repeating? What would that mean? That I was going faster, okay? So I can change the period of this by going faster, okay? If the period were slower, if the period were longer, then that would be a slower pedaling bicycle, okay? So just another example of something that we can model with a trig graph. So before we commence with that, let's just take a look at and review some of the things we did from the last quiz. Now let's look from 0 to 2 pi. Okay, so from 0 to 2 pi is from here all the way over to, let's see where I can see it, right here. Okay, so let's look at the graph on that interval. Okay, what is the amplitude of this graph? You might have to look at, let's just look at the numbers then. Yeah, the amplitude, so here's the 0 axis. It goes up 1 and it goes down 1. The amplitude is 1, okay? The amplitude is 1, right? The period, how long until this graph starts repeating? Yeah, 2 pi, so the period is 2 pi, okay? Has this been reflected? What kind of graph is this when you look at it? What would be the other answer? Cosine. This starts at 1, it ends at 1, halfway in between is -1. This is a cosine. Is it reflected? No, because the cosine graph looks like this, so it's not reflected. Has there been a vertical shift? Yes or no? No, I mean it's at the x-axis there, so there's no vertical shift. Is there a phase shift? Has it moved left or right? No, it starts here at 0 and ends at 2 pi, so there's no phase shift. What is that equation? From 0 to 2 pi, what is that equation? Yeah, that's just cosine of x. That's all that is, okay? So, and we just learned to recognize that by knowing that one period of the graph, the cosine starts at 1, ends at 1, halfway between is -1, halfway in between those 2 points, it is at 0. Okay, so if you're looking at from 0 to 2 pi, you see the graph of cosine of x. Now, what we can do is let's look at that same graph, but now only look at it from pi over 2 to 5 pi over 2. Let's look at the graph that is in blue. Okay, this thing starts at what? What's that value? But what's the y value? It ends at halfway in between is 0. What kind of curve is this? This is a sine graph, okay? So what is the amplitude of this one? Amplitude, how high does it go? It goes up 1 and down 1. Amplitude is 1, okay? What is the period? So here, if you look at this blue graph, here's where it starts. It starts repeating here at 5 pi over 2. So how do I find the period? It's 5 halves pi minus what? Minus pi over 2. It starts at pi over 2, ends at 5 pi over 2. What is it? This is what? 4 pi over 2. What's another word for 4 pi over 2? Yeah, 2 pi. So this period is 2 pi. Has this been reflected? Yes, normally a sine function would look like this. All right, so this one has been reflected, so it is reflected. Okay. Has it been shifted left or right? Normally we would start the sine where? At 0. It's been shifted what? Yeah, so it's been shifted pi over 2 to the right. Is there a vertical shift up or down? No. Okay. What is this equation? Is that what you said, or did you say something else? There's one other piece missing here. Look at all this information. What am I not reflecting here? Yeah, the negative. It's negative. Negative sine x minus pi over 2. Okay. So what you can see, guys, is that we've been learning sine and cosine. They're really the same thing. Okay. This is just the same graph. If I look at the graph, if I start looking at the graph here, it's a sine function. Okay. If I start looking here, it's a cosine function. So really, by shifting the sine curve, you run into the cosine curve anyway. So in these models, when we look at something like this, depending on where you start or where you look at it, you could have multiple answers that could be correct. There could be a cosine graph that's correct or a sine graph. So there's either way. These are the same curves. Negative sine of x minus pi over 2 is the same as cosine x. So depending on where you look at it is what equation you call that. Okay? So that's the skill that we'll need, is being able to look at graphs and come back with the equation. So another concept that we'll need today in these word problems is the frequency. So if you think about it, when I'm pedaling the bike, what if I say that I can pedal it if I can make three revolutions per second? Okay. How many? If I make three revolutions in a second, how long does it take for me to make one revolution? So I can make 3 revolutions in 1 second. How long does it take me to do one revolution? 1/3 of a second. Okay, so if I can do 3 of them in 1 second, then 1/3 of that time I will have done one of those. Okay, so in this one, if you can pedal 3 revolutions in 1 second, then each revolution takes 1/3 of a second. Okay, so this is how you convert from frequency to period. Okay, so if the frequency is 3 revolutions per second, then the period is going to be 1/3, because if I do 3 revolutions of that bike in 1 second, that means in 1/3 I've done 1 revolution, so it repeats after 1/3. So the period is that. So if I give you the frequency of something, then the period is just going to be 1 over the frequency. Okay. So for example, if I can do, 10 laps around this building, in an hour, then that means that, well, 1/10 is going to be the period, so 1 over the frequency. Okay, so anytime you have a problem that has frequency, remember the period is going to be 1 over that number. So let's take a look at a few examples. Okay, Now, the skill you're going to need with this, you're going to be able to read the word problem, and you're going to need to be able to draw this stuff out, okay? And by draw it out, you need to label it correctly, and that's how you're going to get the information that tells you back what the trig function is. So a mass on a spring has been raised 4 centimeters above equilibrium and is then released. The height of the mass will follow sinusoidal movement. That means it's going to follow a sine or cosine graph and vibrate with a frequency of 2 cycles per second. Graph the motion that shows the height as a function of time. Write both a cosine and a sine model for this motion that gives the height in centimeters as a function of time in seconds. Okay, so the frequency is what? Yeah, the frequency, so I have a frequency is 2 cycles per second. Okay, what's the relationship between the period and the frequency? So if something can happen 2 times in a second, how long does it take for it to happen 1 time? If it happens twice in a second, half a second. So it's just, the period is just 1 over the frequency. So the period is 1 over 2 is going to be the period. So the period is 1/2. And this is where we're going to start to graph. The graph is going to inform us as to what needs to happen here. So I'm going to draw, this is going to be my axis at 0. Okay. So if the period is 1/2, how do we always graph trig functions? I counted out what? How many spaces did I count out? 4. So if this is 0, let me just label it. We'll put 0 right here. 1, 2, 3, 4. I'm going to call that 1/2. Okay. Now what's happening here? This is going to be time. How is time measured in this problem? Time is measured in seconds. Okay. And I'm measuring against what? The height of that spring. How is that measured? Centimeters. Okay. So this is the height in centimeters. Okay. Okay. So now when this experiment starts, before I start my time clock, what do I do to that spring? What do I do to it? What does it say? What does this problem say that I did to that spring? I raised it how much? Okay, so I go 1, 2, 3, 4. That is where my spring is, okay? Now, what am I going to do to that spring? I'm going to do what? I'm going to drop it, but I know it's going to return to its original state, right? When will that happen? Well, it's going to happen after 2 cycles, but it's also going to happen after what? 1 cycle, okay? So what happened is I lift it up at 4 centimeters. It's going to do 2 cycles per second. I'm going to graph 1 cycle here. So where's it going to be at 1/2? Where's it going to be? This is the end of a cycle. Where will it be? Back up where it started, okay? Okay. So it's going to end up back where it started. And then halfway in between here, where do you think it's going to be? Yeah. It's going to be here. Okay. So it's going to, when I raise it up, it's going to go, so it's resting right here. When I raise it up, it's going to go down below the resting point, okay? So it's going to keep doing this same motion, okay, over time. So then you can see, what do you think is going to happen halfway in between here? Okay. What do you think happens halfway in between here? 0. Okay, so we're going to see something that looks like this, okay? What does that look like? Yeah, so if I'm looking here, this looks like a cosine graph, okay? So what are the things that I need? I'm going to need to know, so what is some of the problems later I'll ask you, but what is the amplitude? Yeah, it goes up 4, it goes down 4. The amplitude is 4, okay? What is the period? Yeah. The period is 1/2. Okay. And I think that there is no phase shift. It's starting at 0. There's no vertical shift because I'm here at the x-axis. Okay. Now, to find the period, I'm trying to write something that looks like this. F of x equal a cosine b x minus h plus k. Okay. A is going to tell me what? How will I figure out what A is? The amplitude. How will I figure out B? I need to know the what? The period. Okay. So if I know the period, how do I solve for B? B is what? B is equal to 2 pi divided by the period. Come on, guys. We were quizzed on this last week. B is 2 pi over the period. So in this case, B is going to be 2 pi divided by 1/2. What is 2 pi divided by 1/2? 4 pi. Okay. There's no phase shift left or right. There's no vertical shift. Okay. So what is this? What is the function here that models this? This is going to be the height as a function of time is equal to what? 4. Okay. 4 times the cosine of what? 4 pi, and then my variable, 4 pi t. So that's it. So by doing this graph, I can see here is a cosine curve that models this scenario. It has an amplitude of 4. It has a period of 1/2. 2 pi over 1/2 is 4 pi, so B is equal to 4 pi here. Okay. And then it has no phase shift. Okay. Does everyone see how I got that? I mean, should follow on with what we did last time. Now, here's the catch that we're going to be throwing in here that we didn't do last time. Let's also come up with a sine model. Okay, sine starts at what? 0, ends at 0. Halfway in between is 0. Okay, so here's something that's starting at what? 0. Okay, so what is this value? So if this is 1/2, what is this number right here? This is 1/4, right? Everyone see that? Okay. And then if this is 1/4, what is this? What's half of 1/4? 1/8. Okay. So this looks like a curve that's been shifted to the right by what? 1/8. Okay. So this is a sine curve. What's happened to that sine curve? Tell me everything that's happened to it. It's been reflected. It's been moved to the what? 1/8 to the right. What's its amplitude? 4. Okay. So we need to figure out that. And then the vertical shift, there's no vertical shift. So the sine curve, so if you look at the sine model, it has an amplitude of 4. The phase shift is what? 1/8 to the right. And it has the same period. The period did not change. Okay. So if you've got the period here, this is going to have the same period. So someone tell me what the sine model would be for this. H of t is what? Yeah, -4 sine 4 pi t what? Minus 1/8. So sorry that ran it. So -4 sine of 4 pi t minus 1/8. Okay. So both of these are the same models. Okay. How high was the weight at 0 time? How high was it? At 0, what did I do to that weight? I raised it 4 centimeters. So what happens if I plug in 0 here? Okay. What is the cosine of 0? On your unit circle, if you're at 0, what is your x coordinate? Come on, guys. No. At 0, what is this coordinate? Okay, what's the cosine of 0? Cosine of 0 is 1. What's 1 times 4? 4. So that tells me, yes, this thing is 4 centimeters high at time of 0. Let's try it here and just see, okay, if I were to plug in, let's plug in a 1/8 here. What's 1/8 minus 1/8? 0. What's the sine of 0? Sine is what coordinate, guys? Y. What's the sine of 0? 0. What's 0 times 4? 0. So it tells me at 1/8 the height is 0. And that's what I see in my graph there. Okay. So guys, the real critical skill here is you've got to be able to draw the graph. Some of you had trouble drawing the graph and putting numbers, okay? That's a skill of humanity that you need. You need to be able to put numbers here so when your teacher is looking, they know what things are, okay? I tried to be a little bit lenient the last time, but this skill is pretty critical here for labeling. There's not a whole lot new that I did here. Like once I knew the period, I counted out 4 spaces. I drew the graph, okay? But what's different here, instead of seeing things like pi over 2 and pi and 3/2, you're seeing numbers that represent seconds, okay? So that's one of the differences there. Okay, let's take a look at another one. Bicycle pedal. So a bicycle pedal has a maximum height of 12 inches and a minimum height of 4 inches above the ground. If you can pedal at a frequency of 2 cycles per second, graph the motion of the pedal and give the trig model the height of the pedal as a function of time in seconds. In all of our models, guys, the x-axis is going to represent time. It may be minutes, seconds, hours, you don't know that, but this is time in seconds. What is the y-axis representing here? Height measured in what? I heard centimeters, but I'm going to go with inches, okay? Height in inches, okay? So the independent axis is going to be, that's my time in seconds. The dependent axis vertical, that's my height in inches, okay? Now let's just draw what happens here. Describe to me what happens. The bike pedal starts at where? 12 inches above the ground. And then how low will it go? 4. When it completes 1 cycle, where is it going to be? At 12. So it's going to get back to 12. So let's figure out what the period is before I graph this. What is the frequency here? Yeah, so if the frequency is 2, the period is going to be 1/2. So in 1/2 second, my bike pedal starts at 12 inches, and then in half a second, where is it? Back at 12. Okay, so I'm going to start. So let's just see in terms of labeling this guy. I'm going to start here. Let this be 0. And here. And let's just see 5, 10, 15, 20. I do have an, what is it, 20 and 4? Is that what they said? 12 and 4. Okay. So let's just label this 5, 10. Okay. So where does the pedal start? Starts at 12 inches above the ground. Okay. And then my period is 1/2. So let's just count over 1, 2, 3, 4. And where am I going to be there? I'm going to be back where I started, right? That's what the period means. The period means that's how far until I repeat. Now you could bunch this up. You could count 1, 2, 3, 4. I just like to spread out wherever I can. Okay, so I counted over 1, 2, 3, 4. That's the end of my period. That's the way we've always graphed these guys. Okay, so that's where it's going to end right there. Now where's the low point in this graph? How low does it go? Where is that going to happen then? Halfway in the middle, right? At 1/4. What's the low point? It's 4, okay? So I know that so far. That's all that I know at this point. Now, how am I going to figure out the amplitude? The amplitude says from some vertical line, whatever distance I go up, there's an equal distance I go down. So it's going up to 12 and down to 4. What's the distance between 12 and 4? 12 minus 4 is 8. Okay. So that means the total distance is 8. What's the amplitude? Not 8. 4. Okay. So if you think about it, this total distance is 8. So to find the amplitude, you've got 12 minus 4, and you're going to divide that in 2. Okay. So 12 minus 4 over 2, that's 8 over 2. That amplitude is 4. Okay. Well, because the bike pedal, it's the maximum height is 12, the minimum height is 4. So that means the top of my graph is 12, the bottom of my graph is 4. That distance is 8. Okay, and to look at amplitude, amplitude is an equal distant up and an equal distant down. So 8 divided by 2 is 4. So the amplitude is 4. So if I look at this, if I count up 4, 1, 2, 3, 4, I'm going to draw a line there. What do you think that represents for my graph? What where the x-axis would be, we call that what kind of shift? A vertical shift. So this looks like a trig graph that's been shifted up how far? This looks like it's been shifted up 8, okay? From the bottom, okay? So now if we look at the graph of this guy, this thing starts out here, it ends there. Halfway in between, where is it going to hit? Yeah, it's going to hit 0, which is this vertical shift. Halfway in between here, this is where it's going to hit. And now you see our cosine function. It looks like this. So the amplitude is 4. The period is 1/2. The vertical shift is what? Vertical shift is 8, okay? And now if the period is 1/2, how do I go from the period to figure out what B is? The period, B is what? It's 2 pi over the, B is 2 pi over the period, okay? So B is 2 pi divided by 1/2, which is 4 pi, okay? So now you know enough to write this model, okay? So let's write the model for cosine. The height of that bicycle pedal, h of t, is, what is the cosine model? 4. Yeah, so 4 cosine, B is 4 pi, and then t. Okay. So that is the model for the cosine of this particular curve. Now, let's look at what the sine model is going to be. And it should follow pretty closely. If this is 1/4, what's halfway between 0 and 1/4? 1/8, okay? So if I look at the curve from here, starting at 0, what kind of function would this be? This would be what kind of sine function? Is it reflected or not reflected? Well, yeah, normally the sine goes up. So the sine model is going to be h of t equal. The amplitude doesn't change. It's just a reflected sign. -4 sine 4 pi and then t minus 1/8. So when I look at this curve right here, because it doesn't start at 0, that's a perfect setup for a cosine function, okay? But if I look at it starting here, that's where a sine curve would start, but it's a reflected sine curve, and it's moved 1/8 to the right. Was there a question? Okay. So again, one of the calculations here was to find the amplitude, it's the maximum minus the minimum, and you divide that by 2. Okay, that's your amplitude. And then if you take the amplitude and you take the minimum, add the amplitude, that gives you a vertical shift. Or subtract the amplitude from your maximum, that tells you where that vertical shift is going to be. Questions over that? Now, I mean, these aren't that difficult, are they? I mean, doesn't it follow what we've been doing? I mean, come on, guys. I know it's Tuesday, but, you know, you guys can do this. Let's look at another example. See, good. We have a good example, Ferris wheel. Okay, you and your friends decide to ride the Ferris wheel at the fair. You enter the ride like everyone else who always enters, and notice that you're 4 feet above the ground. That just sounds like a sort of geeky thing to do, but at the top of the wheel, you're 40 feet from the ground. If the wheel takes 2 minutes for a complete revolution, graph the function of the height of the wheel and give a trig model. Okay, so what is my independent variable that goes on the x-axis? What is that always in these cases? It is time. In this case, we're going to measure time in what? Minutes. Okay. What is my dependent or my vertical variable? Yeah, it's the height in feet. So let's draw what is happening. Where do I start the Ferris wheel? Where do I start it? At 4 feet above the ground. Okay. So, and I got to go to 40. So let's just see. And here's what you get. You got to make your vertical axis. So what if I go 10, 20, 30, and 40? That will give me enough to map everything. What you don't want to do is to graph it like 10, 20, 30, 40 down here, just all bunched up. You want to try to spread things out, okay? So where do I start? At 4. So that means 2, 4, 6, 8, 10. So right here, that's 4, and that's at time 0. That's where I start, okay? And where is the, so how do I figure out the amplitude before I graph it? What's the maximum? Yeah. Yeah, so this is 36 over 2. This is 18. The amplitude here is 18. Now, how do I figure out the period? The period is the time it takes for it to, until it starts repeating. What does the problem tell me? 2 minutes for it to repeat. So the period is 2. Okay. So what I'm going to do here, I'm going to count 1, 2, 3, 4, and I'm going to call that 2. That's the end of my period. Okay. If that's 2, then what's halfway in the middle? 1. What's halfway between there? 1/2. Okay, so this is the skill that we used in graphing all of these trig functions. Okay, so it starts at 4. Where is it going to end up? At 4, because that's the complete cycle. Okay, and then halfway in between, where am I going to be? I'm going to be at 40. Okay, so halfway in between, I'm going to be at 40. So you can see what's happening. What does this look like? It looks like an inverted cosine, right? So halfway between these 2 points, so let's look at it. The amplitude is 18, right? So where is my vertical shift? If the amplitude is 18, that means I go 18 feet above something and 18 feet below something. I got to find out where that point is, okay? Anyone know? Okay, if this is the minimum of the graph, okay, and this is the maximum of the graph, okay, if I either subtract 18 from this number or add 18 to this number, I should end up in the very middle, right? What's 18 plus 4? 22. So right here at 22, that's going to be where my vertical shift is, okay? So in this case, since the amplitude is 18, my vertical shift is going to be 4 plus 18, which is 22. So if I look at this graph, halfway between these 2 points, where do I expect my graph to be? A 0, but it's where this 0 is right here on that vertical shift. And then halfway between these 2 points, I expect it to be right here. So we see something that looks like this. Okay. So this looks like a what? Yeah, a reflected cosine. Okay. So if we look at this, so to write the cosine model, so it's a reflected cosine, so it's h of t equals minus, what's the amplitude? 18. and then it's cosine. If the period is 2, how do I figure out? B is going to be what? 2 pi over the period, which is what? Pi. So 18 cosine of pi t, and then there's a vertical shift of what? Yeah, plus 22. Okay. So that's the cosine model. Negative 18 cosine pi t plus 22. Okay. Now, where would I go to figure out the sine model? So this is starting at 4. Sine always starts at where? Come on, guys. Sine starts where? 0. Ends at 0. So I go to this curve. Where does it look like it's hitting at 0? Yeah, right here. Okay. So this is where a sine function starts at 0, ends at 0, halfway between a 0. So how would I figure out a sine curve? What's the only difference between that cosine? This has been shifted where? To the right by 1/2. And is this a sine function or a reflected sine function? A sine function because it goes up. Okay. So the sine model is going to be h of t equal, amplitude doesn't change, 18 sine, period doesn't change, but it's been shifted where? Yeah, 1/2, vertical shift does not change. Okay. So once you get one of these, it's fairly intuitive to get to the other one, right? What's the hardest thing about these problems? Nothing? What's hard about it? Is it drawing it out? I don't know. So, yeah, so they're going to be reflected. I guarantee you on the test, you're going to have either a bicycle pedal or a Ferris. I mean, the numbers may change. I'm not going to throw something at you like they have never seen a problem. So I've worked problems here. There are 3 or 4 problems in your homework. I guarantee you on the quiz, it's going to be something from one of those that you've seen, okay? Like I said, the numbers may change, but the wording of the problem, the scenario, the context is all going to be that. So that should be it. I think that's the last one. Oh, no. What is the height after 7 seconds? How would I figure out how high this thing is after 7 seconds? What would I do? Well, you got to do something with 7. That's a key. What would I do? Just plug in 7. Which of these would you rather work with? The one on the left or the right? The left. So let's just plug in t equals 7. So we're going to have h of 7 is negative 18 cosine 7 pi plus 22. Okay. Now, where is 7 pi? This is 0. This is pi. This is 2 pi. What is this one? When I come back around, this is what? Well, pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi. 7 pi is going to be right here. What are the coordinates there? Okay. Definition of cosine on the unit circle. What coordinate is it? The x. Cosine is what coordinate? X. So what's the cosine of 7 pi? Negative 1. So what is negative 1 times negative 18? 18. What's 18 plus 22? 40. Okay, so this tells me that this thing is 40 feet at 7 seconds. So where does that mean you are at 7 seconds? You're at what? You're at the top of the Ferris wheel. Okay, so that's it. Pardon me? So, so that is it, guys. So one of the big keys here is you got to be solid on the graphing, what we did earlier, and then things here with period and frequency. Okay? I will see you guys tomorrow. Please take a look at the homework between now and then.